Assalamu alaikum.
Walaikum Salam, sir.
I think some people are not joined yet. So we will start our today lecture. Yesterday, we have made a 50 kilowatt layout for the simple structure on the rooftop. So today we are planning to make a layout for the 100 kilowatt for the 100 kilowatt for the ground mounted system, and in which we will see that how we will make the O&M buildings like in the large scale projects. We have to given the O&M buildings, the transformer area, the other things, and the roads and other things. So in that lecture, we will make a short uh, s- mm, and comprehensive 100 kilowatt systems to give you the overview how we will make a layout for the ground mounted systems. So wasting our without wasting our times, we just move to our lectures. Yes, Amar.
Sir, could we make the project for the best projects like layout?
Best.
Yes, best.
Brother, sorry to say that I'm not much experienced on the best sides. I have just made the 3D layouts for some my clients, but actually just I have placed the containers as per the manufacturers, but not yet any layout or any other things. In the details, I don't have work on that. I'm planning to gain the experience in that field, and then maybe I will give the short videos on my YouTube channels. At that time, I don't much have experience that, so that is why I'm just saying that I'm not want to add anything which I don't have any experience, because I don't want to share the false knowledge on that platforms, because I am sharing that videos on the YouTube's privately, but some people are seeing that videos and they gaining the knowledge, and if I uh, mm, share the false knowledge, that is not a good for me as a personal, as a career wise, so that is why I'm not going in that details. Okay, Bar.
Fine, sir.
Okay, thank you. Okay, don't waste our time and just move to our today lectures. I'm just sharing my screen. So yesterday, in that same file, we are just making the layouts on the ground mount systems. Here, I just made the layout for the rooftop systems. Now, today, we are making the layout for the ground mounted systems. So here, I just have like here, I will make a short area for the ground systems. Like here, I just made a layout area. Okay. So here is the area. Now we will place the same like that area in the 18-degree or 15-degree tilt angle, same like that. Panel in the portrait, 2P structure, and make them the 30 feet the row spacing, and then we just continue that structures. Okay. Now I'm just checking that. I'm just checking uh, how many panels are installed there. So here just 1396 panels are installed, 715. So it around 1 megawatt system is installed here. So what will I do? I just make a short here, delete that to make the area for the uh, pa- uh, substation area like that one. And I just make one panel from that area to make for the road spacing like there. So here I have just made that layout, and now I am just checking 936 PV module are installed, 715. So it around 670 kilowatt systems is installed there. So here same structure will be used. Same structure will be used like here. I just made on the rooftop. Okay. Mhm. Right. And just make them as a group. Okay. Just move that one and line them one. Okay. Now rotate them and align them with that. Okay. Now it's aligned. Now we just move that file and just delete that one and light and same like that. Okay. Now move on to actual, sorry. So here, okay. Now I'm just click on that, exploit them. Okay. Okay. Now I'm just making that layout. Same like that, center to center distance, and then give them like 100 multiple. You give them multiple, it give them that numbers. Okay. Now we just now just I'm pushing that to the end because this structure, the C channel. Because they are the same component. So when I am increasing the length of that purlin, it will like increasing the length of the purlin which are present on the rooftop. So that is why we just click on that four one and make them as make unique. So when we make them unique, it will not affect the length of the. So here, so here it make become the proper ground mounted structure detail. So now what I will do, I just click on that, click on that, and click on that. Make them as a group. Now it's become the overall group of that structure. Sorry, sorry. Exploit again. Make them unique one, and then select this overall. Now make them as a group. So what I will do, just copy these here where I have placed the layout. I just here, here, because they are the same length and this will also the same one. So now I just delete all these three lines. Okay, and same like that. Okay, now just copy that one here, 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 and here. Now it's become the layouts with the proper structuring for the ground mounted systems. Now, what we will do, we just making the fence around that one, like here, 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 and here. This is the like the fence available. So we make them 2.5 meter means 3 into 7.5 feet around. So we are just making 7.5 inches feet fence around that. Now we are checking that if it creating a shadow on our system or not, because we have to check the shadow analysis of that one. So you can see that they are creating the shadow at the noon time. So what we will do, we just move that outside of that area. Okay. Now we will just check uh, the noon time. Here you can see that they are not creating the shadow on that and also in that region. So here we have make them one layout for that one. Now we just making here we just create a layout that move the fence that area outside of the fence. So now we are making the roads for that area. Like we have that fence around that region, 4 meter in the area like here. So here is the road. It is around like 200 mm, 250 above the area. We just make the road. Now we give him them the colors for the road area. pattern, window coverage, asphalt, brick canal. I'm just checking any area which is related to the ground pattern. Like this one. Uh, any roofing, stones, that is tiled. This one. We have we have made the road area. So here we have made the ground mounted system layout. Now fence also we have placed that. Now we are making one building there for the O&M purpose. Like here we have made them uh 15 feet by sorry 15 feet by 18 feet or 30 feet. One room for O&M purpose. Okay. Give them the height of like 15, 20 feet height. Roofing that one, and then coloring. Okay. Now we have make one building there. Now we just making the the rooms, doors there. One room there. Okay. Erase that one. Sorry. So here we have just given uh, the gate to the buildings. I think we just need to decrease some height, like 10 feet. Is it okay? So now it is O&M buildings. Like we have to make the area for the transformer and other things. Okay, like I'm just showing the buildings there for the transformer and other things because I don't have any specific model for that area. So you can like here just I'm giving them 5 feet height. So this is the transformer area. Then we making the trenches there. Like we have to make the trenches for our buildings. Like here we have trench there. We have to we have to install the inverter there. We make the trench there to reach out to the transformer area, like 2 meter or 1 meter. Okay. Now it's become the trench area. We just give them the color like green color. What is I show? Why are they not creating that one? No. So here is the the trench area. Now we are making the trench for that area also. It should be like crossing 1 meter, 1 meter. So here is the just trench area. I have marked that one. And also we can install our inverters there. And here we have to give them the gate in that area. So here is the overview of that solar structure for the ground mounted systems. And I think I have just explained the things which we shall be needed. They are not good. So here I just make them this small layout for that area. Now you can ask me the question if you have. So tomorrow we will make one layout for the customized structure which are installed on the rooftops. And then in the last lecture, we have two lecture remainings. One for the we make a layout on customized structure, and one for the tilted rooftop structures. We will make the layouts, and then we will install the things here. So now, if you have any question in that, you can ask.
Sir,
Yes.
sir, could we just like the PV module, we connected them in the series or parallel on the SketchUp or not?
It's too much difficult. It's too much difficult. We
But
can make,
if our client
we
say
can,
that, uh,
no, no, client don't say in the SketchUp files. They just ask us to prepare the series connections, like the strings connections in the AutoCAD files. Because you can see that, like here, when you make them as a connection, how you will show them in the video you will send to the client. How will you will show them how they are connected in the series? You can't show in the in the 3D files. For the series connection, you have to show to the in the AutoCAD files. You can do that, but it's very difficult because SketchUp has a limitations, has some limitations. Like what type of limitations? They have just the upper view and the large number of the panels and the structure, other things. You can do that. For the cabling type and the piping work, you should use the solid work. I think solid, like the software is used. But most of the time, I don't see that the client, because I have worked on the large scale project, like the international client and other things, and client will ask you to submit the AutoCAD drawings as official. You just use the SketchUp in the local level, like in the Pakistan levels. Mostly, you should use the SketchUp files for the printing, how your rooftop will show them when the solar system will installed. And also in the large scale project, you just show use that SketchUp software for the shading analysis, other things, mostly for the shading analysis things. Yeah, there I have show how we will see the shadow of fence and the PV modules and the MV station there and other things, what they will impact on that. Okay,
sir,
Mark?
what? Yes, sir, I got it. But sir, how you use the shadow analysis in this project? Could please repeat this?
Yes, yes. Okay, no issue. I'm there for your guidance. Like here, uh, I think people, right? Like here, uh, in the Pakistan, in the Pakistan area, like because we are in the north hemispheres, and our PV module installed in the south directions. So In our regions, the shortest day is December. Shortest day is December. And at that day, the shadow should be the longest. So here you just select uh, the month. I have selected the December. Here is the cursor for the shadow analysis for the time zones. Here I can show you, if I will show you here. Here you can see that when you will enable the shadow analysis, shadow. Here you can see that it should be the 9:14 a.m. Pakistan time and 12:31 is the last day. We will select that the 22 is the shortest day. So here you can see that the shadow is present. Shadow is present. Like here you can see that our shadow will go in to the downward, not on the panels. Any panels will be affecting from the shadow. Okay. Here in that region, you can see that shadow is going outside. Here you can
Yes,
see that shadow is going. Yes.
yes, sir. Yes,
Yeah.
sir. But it also affect the PV module, sir. It
When
reduces the generation of the solar.
yes, when shadow is present on the PV modules, it also affect their generation. It also affect their generation. Okay. But here you can see that the shadow is not present on the PV modules. It is only under the PV modules. You can see that at the 9 a.m. is the shortest day. And mostly client will ask you to give them the shortest day, 9 to 3 p.m. 9 to 3 p.m. The clearest time, 9 to 3 p.m. Or some client will require that we have to give them the time zone like the 20 degree. At 20-degree angles, sun angles, the shadow will not present on the PV modules. Okay. So I think I have just tomorrow I will install a one angle there, sun path there in the extension available, but I will show you in the tomorrow class. They will show that at the 20, like in I have one project is in the running phase, and client consultant has asked me to show the shadow analysis of the MV stations on the PV module and other things at the sun angle less than 20 degree, sun angle less than 20 degree. So we have show them through the uh, that angles. But here I have uninstalled that extension. Tomorrow I will install that extension and show how we will show the angle through. But at the shortest day, you can see that no shadow is available at 9 p.m. Now we will just move that to the 12 p.m. That is the maximum time. Like there, you can see that they are the clear. No shadow is present on the PV modules. Okay, here. Now we move on to the 3 p.m. 3 here. You can see that no shadow is available. Just show going under the PV modules. Going under the PV modules, no shadow. Here you can see that our fence area is that and no shadow is available there. Okay. So here is a just like show how we will do the shadow analysis on the PV modules. Okay.
Okay, sir. If we choose another day of December, like, okay,
Because
the
uh, the
huh.
shortest day, uh, if you use any other day, you can use. Like I have selected the 21. You can use the 21 December. You can see that. No shadow is available. No, you can see that. Zoom out, zoom in. Okay. So because at the shortest day, the uh, the shadow is lengthy, too much lengthy. Now you should go into the June area, like July. We will select the July area. Now you can see that no shadow available in that time.
Yes, sir.
You can see that too much
Yes,
small
sir.
shadow at 3 p.m. Now you can go into the 5, like 5 p.m. Around 5 p.m. No shadows available. So it depend upon the times, because we have to give them the clearest time, 9 to 3, and the shortest day. Shortest day. Okay. So shortest day is 22 or 21 December in Pakistan, in the southern hemispheres. Also, sorry, north hemispheres. Like in the South Africa where we are working, this is in the southern hemispheres, and the shortest day is 21, 22 Junes. So here we have to show them that June's area clearest time. Okay.
Yes, sir. No, if the shadow is appeared all the day or in the peak generation time, so how we get rid out from this the shadow?
Then we have to remove that panels. We have to eliminate that area without if the client, like some client require that, we have to meet that capacity. Like in previous year when I am working in the Pantera Energy, here one client has asked us to give me that 100 kilowatt systems, but their area is too much small, and some things are available on the rooftops, that creating the shadow. When we do that shadow analysis on the SketchUp and PVSys, we have gained that they are creating the shadow on the PV modules, like in the 2 p.m., like 2 1 or 2 p.m. they are creating the shadow on the shortest day. We have clearly mentioned to the client that we have to remove that panels, and in their capacity not meeting 100 kilowatt. The client said that no, you should install the 100 kilowatt, no issue. If the shadow is creating on in the shortest day like December, we have the load capacity in load demand in that time is too much low, so no issue. In the summer days, there is a no shadow there available, and we have too much load there, so we have no issue, you can install the systems. So here in that case you should install what client it's your responsibility to convey every truth to the client. But if the client is agree that no issue, its shadow is creating, no issue, you can install the system, then you have no issue. But if the client says that we require the solar system without without shadings in that peak times, then you have to remove that panels and install that panel any other location. Like here, we have area that available. We have area that available. If fans are creating the shadow, you should just move that panel. Uh, like here we just click on that, move that panels close to the fence. Like here I just move that. Now you can see that shadow is not available, like December. Now you can see that. No shadow is available in that times. 5 p.m.s, like 3 p.m.s. No shadow, just clear. Okay. So it is the like the way how we will uh, clear the fence, the panels from the shadow. Okay.
Yes, sir. No, if we move the no, we move the panels on the layout, but not in the real, right?
No. Your basically your layout is your actual actual installations. When you are making a design for your company, your installation team will follow that layout. Not they want their own installation. They
Yeah.
just follow their layouts. You will
Hmm.
just mention, like here, here is the area. What we will do, we have just give them uh, here, no, like 5 plus 5 plus 5. Yes, this one. So, like here, we have to give them that uh, coordinate or length is like what is the length from that angle and what is the length from that angle. You have to give them that coordinate. Then your teams will install the solar system at that locations. At that location. Basically, when you are doing in the AutoCAD, you have to give them the coordinate of that locations, of that piles, of that footings to the teams. Okay.
Okay, sir. Thank you.
Okay. Mr. Greg, have you any questions?
Yes, just a question. I've seen you moving uh, the panels to the fence back and forth. So I'm wondering, I would like you to talk about the minimum clearance from one panel to the other. Isn't there like a risk of them being too
Shadow.
close, or
Uh,
are we not following that? We are just following the sketch.
basically, we have this is like the this is we can say that this length from this length it should be the pitch area. You can see that it is pitch. We have to give them the pitch. Minimum pitch is should be as much as possible. We have to utilize the area to minimize the pitch. If your pitch is less, your coverage area is, your GCR value is higher. But if your pitch is on higher side, your coverage area is lower with the PV modules. So you have to optimize that one. Like the pitch should be minimum that one in that area at the shortest day. Your PV modules front shadow, like this shadow is not creating the shadow on the back PV modules. This is the pitch minimum pitch length. Uh, it should be the pitch should be how much length, how much number. It should not creating the shadow on the back of the PV modules. And also, if we like too much lower side the pitch area, pitch length, pitch value, that creating the shadow, we have to increase the pitch area. And also, we have to not too much increase the pitch area that there is a no shadow effect and our coverage area is too much lower sides, and we have to increase the total PV plant area to meet the capacity. It is not a good practice. So you have to optimize both the things. You have to optimize the GCR value, and you have to optimize the pitch, which is not creating shadow. But mostly you have to like give them the pitch should be minimum, sorry, GCR value should be less than 50%, less than 50 or 50%, maximum by 50%. You have to follow the GCR value. And I will show you the formula for the GCR, how we will calculate the GCR in the tomorrow or in next lectures. I will show you, but you have to wait for the uh, end of that sessions. Most of the questions you will see in next lectures. You will see some things I will added in that lectures, but it should be optimized one. Okay.
No. Okay, okay. I think I'll wait for that because right now
Okay.
I'm waiting to start project on ground mounted system. So yeah.
That is basically the ground mounted system, no? That is basically the 600 kilowatt I have installed in the ground mounted system. It is basically the ground mounted
Yes.
systems. Like you can see that I have installed the fence area, like O&M buildings, and then for the transformer area, then the trenches, the roads, I have like made them. to show how we will show to the client if your client is asking for to show the 3D sketch of that area.
Yes, yes, yes. Thank you, thank you.
Okay. Okay. Okay, guys. No other
Yes,
questions?
yes, yes.
Okay. Thank you. Thank you, guys. We will meet again by in the tomorrow class, inshallah.
Good night. Thank you.
Good night. Good night.